Hi, Jake.
Hi.
How are you today?
Hello?
Sorry about the difficulties. I came up to my office and my computer wouldn't work, so I had to reboot it.
No worries. It's cool.
So I noticed you had your webcam on there for a moment.
Yeah, I actually put it on.
Yeah, I've forgotten what you looked like. I have one on my end, but I don't use it because it requires such a large percentage of my computer resources that it slows everything down a little bit.
Mm-hmm.
So I don't use my webcam. That's why.
Makes sense.
All right. I assume we want to start at 1.
Yeah.
I think your mom sent me 2 pages. And I can see now that you're getting into limits exactly as I thought you would. You can see on problem number 4 some of the problems that I kind of talked about last time we met.
Mm-hmm.
All right, so let's see. What's that mean? The limit of f of x equals 5 as x approaches 2.
It would be like 2 equals 5 pretty much.
No, what it means is here. One thing you have to keep in mind with calculus.
Doesn't it mean that the x value is approaching 2, and the y value is 5?
Exactly.
Yeah.
In other words, that's exactly what it means. This is f of x. This is the x. So as I'm approaching 2, and I could have all kinds of functions that would approach 5 at that point. I could have a function that looked like this. So as I approach 2 on the x-axis, it approaches 5 on the f of x axis. Now, it approaches it from either direction, correct?
Mm-hmm.
In other words, if I approach 2 from the left, f of x approaches 5. If I approach 2 from the right, f of x still approaches 5. So they're saying, is it possible for f of 2 to only be 3?
I think it's possible.
Yes.
Because there could be a removable discontinuity along the...
If we had a discontinuity right there with an open circle, then the limit as we approach 2 from the left would be 5, from the right would be 5. Therefore, the limit is 5. And yet, f of 2 is equal to 3.
Mm-hmm. Because technically it doesn't touch the point, so it can't be.
Yeah, it's a piecewise function.
Mm-hmm.
So when you have a piecewise function, that is an open circle there. But nonetheless, this is the one that's kind of strange. Where the heck did this ruler come from? Let me move it out of the way. All right. So question number 2. Explain what it means to say that f of x is equal to 3 as, in other words, what's this part? And let me erase some of this. What's that mean? What does that mean? Yeah, what does that whole statement mean? The limit of f of x equals what? Keep going.
So that means that the x value is approaching 3. No. The x value is approaching -1.
Nope.
No, just 1, but from the right side.
From the left.
But like it's no, I mean it's
This
going
is from the left.
Could you like draw it out for me so I can like visually see it?
Uh-huh.
Thanks.
So they're saying that as x approaches 1, you have a function kind of like this.
Mm-hmm.
Now, if from the right it approaches 7, there you have the kind of function they're talking about, where if I approach the function, if I approach the number 1 from the left, I'm headed towards an f of x value of 3. But if I approach f of x, if I approach number 1 from the right, in other words, if I approach it from the left, that's what I do. I'm approaching the number 3. If I approach it from the right, I'm approaching the number 7.
And so if there's a plus sign, it's the line is going right. I mean, going left on the graph.
No, a plus sign, well, yes. If a plus sign means you're approaching it from the right. A minus sign means you're approaching it from the left. That's all.
And what if, and there's no sign, it means you're approaching it from the left?
Yeah, the negative sign.
But if there's no sign, like just x arrow 1.
Okay, that's the next question. So now what is f of x as we approach 1? In other words, without the sign, what is it? In other words, from one direction, it's 3. From the other direction, it's 7.
It would be 3.
Nope, it does not exist.
Why doesn't it exist?
Because they're not the same. It's as easy as that. If they are not the same, then it does not exist.
I'm confused.
If they are identical, then it does exist. They're not the same. From one direction, it approaches 3. From the other direction, it approaches 7. As long as those two numbers are different, then the limit as x approaches 1 does not exist.
Because it has to converge on a single point.
No, don't even think of it like that. Has to be the same number.
Okay.
Exactly the same number. If this was 3.1 and this was 3.11, would not be the same number. Limit does not exist. Has to be the same. And let me give you an example. Let's say that I had a function like this. But at 1, the value would be 10, or we'll call it 15. Now, tell me what and this is f of x. So what is the limit of f of x as we approach 1 from the left? And that's what that means. What is it?
It would just be 5.
5? What is the limit as we approach 1 from the right?
5.
So therefore, what's the limit as x approaches 1?
What is the limit as x approaches 1?
First of all, it only exists if it's the same from the left and the right. And we just proved it was. You told me that as I approach 1 from the left, it's going to 5. As I approach 1 from the right, it's going to 5. Therefore, the limit as I approach 1 is what?
5.
Yes, it's not 15. However, f of 1 is 15. This is that very unusual situation where the limit as x approaches 1 is not equal to the same thing as f of 1. And you see why?
Mm-hmm.
Make sure you understand that. This is a very important principle in limits.
Yeah, I get it.
That's why they ask this question. Is it, in this situation, is it possible that that limit exists? And the answer is no, because the limit from the left is not the same as the limit from the right. Scroll down a little bit here. Whoop, yeah, good. So if I have a function, number 3, whose limit, tell me the rest of that. How do I verbalize that?
I don't know.
Well, it says, by verbalizing, and I mean, what it means is the limit of f of x is equal to infinity as we approach -3. Well, let's draw a function that would be the case. There's -3. There's f of x. There's x. As we approach -3, it doesn't even say whether it's plus or minus, but what that means is this. Something that looks like this.
Like a vertical asymptote?
Exactly. On both sides. Let's put our vertical asymptote right there. Now, what's the limit as I approach -3 from the left? In other words, what's the answer to this? As I approach -3, hold on, I wrote it wrong. 1 second. As x approaches -3 from the left, what is the limit of f of x? If you look at the graph, hop on board the function, and when I say hop on board the function, this is what I mean. Hop on board the function and travel towards -3 from the left. Just like that. What happens to f of x? What's it equal? What's it equal to? What's the limit of f of x equal to?
Infinity?
Yeah. So this statement that they mean there would be illustrative of a graph that looks like this. In other words, there would be a vertical asymptote at -3, and as you approach -3 from the left, you go to positive infinity, or if I approach it from the right. In other words, if I hop on board the function and go this way towards -3, I'm also headed towards positive infinity. So that A would be a situation like that. And your answer probably should be there's a vertical asymptote at -3. But you could also draw a little picture like this to illustrate. I hate these kind of questions, to be honest with you. Math should not be answered with words. Math problems should be answered with answers, numbers that are the same for everybody. Whereas when your teacher says, what's the meaning of this? You have to answer it with words. That's going to be open to subjective analysis.
Mm-hmm.
Nonetheless, your teacher asks the questions where she wants words as the answer. Okay, so let me draw a picture to illustrate number B. What kind of function would be like number B? Well, first of all, when stuff approaches infinity or negative infinity, means there's a asymptote, a vertical asymptote. So where's the vertical asymptote here? On number 3B.
On 3B, it would be at 4.
Okay, let's go out to 4. Let's draw a vertical asymptote there. Now the only thing, I don't need to be right and left. I don't need this limit to exist at 4. Because all I need is for it to exist when I'm approaching 4 from the right. So how about this kind of a function? Now, notice what that is. That's the limit of the function as I approach 4 from the right. I hop aboard the function. I start approaching the number 4 from the right. Where's f of x going?
F of x is going to negative infinity.
Exactly, and that's exactly what that says. It says the limit of f of x is negative infinity as x approaches 4 from the right. And that's all I know. I don't really know what's going on the left. They haven't given me enough information. It could be something like this, but it could also be something like that. All I know is that when I approach the function from the right, the number 4, I'm headed to negative infinity, and that means asymptote.
Okay.
All right. Now, this is extremely common here, this picture. And by that, I mean, hold on a minute, let me do this. This is an extremely common calculus question on limits. And we went over something like this, but if you can get all 9 of these right, then you understand limits. Okay?
Okay.
What's the limit of the function as x approaches the number 1?
Would it be?
Now, all 9 of these questions, you're going to have to answer, well, what happens when it approaches that number from the left, and what happens when it approaches from the right? Remember, it only exists if they're the same. If they're not the same, then it doesn't exist. So you're going to have 3 answers. You're going to have approach from the left, you're going to have approach from the right. If they're the same, then it exists, and that's our answer. Well, let's look at the first one. What's the limit as we approach 1?
2.75. I mean 1.75.
What's that value right there?
Oh, dang. 3.
Now,
I'll lose it.
is it 3 from the left and 3 from the right?
Yes.
Okay, so that limit is 3. Now, let's approach negative 3 from the left only.
You mean just 3 from the left?
Well, we're doing this one. No? Yeah. X is approaching. You have to differentiate between f of x and x. X is the horizontal axis. F of x is the vertical axis. But
would not be
say what's the limit of the function? Here's what it means. It means I hop on board the function and I travel towards what number? On the x-axis.
-3.
Yeah. Only I'm going at it from the left. You see the difference between traveling at it from the left and traveling at it from the right?
That's just a +3.
Well, this is what it is. Or, excuse me, I didn't really draw that right. Hold on. In other words, what it really is this point right there. Why they would give you a question that was not on an intersection point?
I'm pretty sure it's just approaching 3 from the other side because it's not.
You're absolutely right. That's what's wrong here. I got it backwards. Excuse me. Here's what's going on. We're approaching that number right there. And we're approaching it from the left. So what number are we approaching?
2.
Now approach it from the right. What number are we approaching?
-2.
All right. So what's this answer?
It does not exist.
Good. That's the easiest answer there is. As long as these two numbers are different. In other words, that could be 2 and that could be 2.00001 and it would not exist. They just have to be the same. That's it. Now, if I look at the graph, what is f of 3? What's that?
1.
Yeah. It's not. Well, this one didn't exist, but even if it existed, f of 3 would still be 1. Okay? All right, now let's go and look at -2 from the left. What are we approaching?
Would it be 1?
Here's our axis. What's this value on the axis right there? Huh.
Would that be? Yeah.
-1.
-1, yeah.
So that's -1. Now what's it when we approach -2 from the right?
-1 still.
Oh, I hate it when they give you these grids that are unnecessarily confusing. Is there some reason they don't give us a grid where every grid is 1 unit? You know what I'm saying? No, this grid, every grid is a half a unit. In other words, to get from the origin to this first one, we got to go up 2 units, 2 grids.
Yeah.
Why do they make it extra confusing? Calculus is confusing enough as it is. They don't need to make it extra confusing by making the grid something other than 1. All right.
Yeah.
That's all I'm saying. So what's f of -2?
-1.
Yeah, they're asking, what's that value? That's what it approaches. In other words, the limit of the function from the left is -1, and the limit of the function from the right is -1.
No, that would be does not exist.
Well, no, hold on. The limit from the left's the same as the right. Therefore, it does exist, for sure. If they are the same, then it does exist.
But isn't that a hole, though, because it's an open dot?
Well, hold on a second. Therefore, the limit is that, -1, regardless of what f of -2 is. The limit does exist, and it's -1.
Mm-hmm.
Now, at -2, see that dot down there?
Yeah.
What's f of -2?
Does not exist.
No, it's -3.
Oh, yeah, I didn't see that dot down there, actually.
Yeah, well, it's hard to see the way they've drawn it. It doesn't stand. I didn't see it at first either. But if this dot was not there and that was an open circle and that's all you had, f of -2 would be does not exist. In other words, if this is not there, then you're right. F of -2 would not exist, but that would still be true, that would still be true, and that would still be true. So you would still have the limits as I approached -2 from the left, the right, and at -2 would all exist. It's really that simple when you're reading these graphs. All right, let's go down to the next graph, which is kind of similar. Guess that's all I can do. All right, what's the limit of f of x as we approach 3?
Would it be?
Always do, whenever you're approaching a number, that means you have to approach it from the left and the right and make sure that those two things are the same.
1.5?
No. Here's how you approach 3 from the, I can't tell. Is that a negative sign? No, it isn't. Excuse me. They're asking about approaching 3. Okay? So I got to approach it from the left and the right to figure out what it is. Well, here's what I do when I approach it from the left. Hop on board the function, and I start going
Positive infinity.
3 on the x-axis. Okay? When I approach it from the right, hop on board the function, I start approaching 3 from the right side. What do both of those go to?
Infinity.
That's the answer. They're both the same, so the answer is infinity. Now, let's look at the number 7.
Negative infinity.
Good. Because from the left it's negative infinity, and from the right it's negative infinity. Okay, now let's look at number C. We're approaching -4, which is that asymptote. What's that answer?
Negative infinity again.
And here we're approaching -9 from the left only.
From the left, negative infinity.
Hop on board the function from the left side of -9 and start approaching -9.
So it'd be positive infinity.
Exactly. This concept of hopping on board the function, I might be the only one that describes it like that, but it's very helpful. Right? So the very last one, what's the limit of that function as I approach -9 from the right?
Negative infinity.
Okay. Tell me the equations of, I'm looking at 1, 2, 3, 4 vertical asymptotes.
X equals 9.
-9.
Yeah, -9. X equals -4. X equals 3. And X equals 7.
Perfect. All right. Let's see. I need to go to the next page here. Let's take a picture of this. Sketch the graph of the following function and use it to determine the values of A. Okay, let's sketch it first of all. How do I sketch this? Think back on your piecewise functions. This is always where you start, upper right-hand corner. And then you work your way down this way. Okay? So, when x is less than 1, what is the function? Excuse me. When x is less than -1, what is the function?
2 minus x.
All right. So, we don't need a vertical asymptote here, but I'll label -1. Okay? What's 2 minus x look like?
2 minus x? It looks like it's going through.
Is it linear? Is it a straight line?
Yeah, it's linear.
Okay. What's its slope?
Negative.
Negative what?
I don't know.
-1.
Yeah, -1.
Whatever the coefficient is in front of x, what's its y-intercept?
It would be 2.
It would be 2 if it went to the y-intercept. In other words, there's the y-intercept at 2, and if the function went all the way, what's the slope is -1. So if I was going to draw the function all the way, it would look like that with an open arrow there. But it doesn't go all the way to x equals 0. It only goes, that's only the function to -1. So I have to erase some of that. And there's 2 ways to do these, incidentally, these piecewise functions. You can do it like this, and then go back in and erase this part right here, because it doesn't get all the way there. It stops right there. You with me?
Mm-hmm.
That's the hard way to do it. What's the easy way to figure out what that point is? I mean, I know the x value is -1.
Calculating the slope.
No, actually, just plug it into the function. If you plug in -1, what's that f of x value?
3.
Yeah. So that's really the first part of the function. And I didn't have to do it the hard way. The hard way was to draw the thing out like it was in y equal mx plus b format, and then erase part of it. The easiest way to do it is just to substitute that value for x, and that's what the function equals when x is -1. Even though notice that this thing never gets to -1, it's less than -1, you can still use that method. It's a little counterintuitive, where you would plug this value in for x, but that's how you figure out that point right there. Okay, now between -1, remember this is the next thing to look at. We've got this part graphed, but we don't have the middle part graphed. What's this graph look like between -1 and 1?
It goes through the x-intercept.
Okay.
I mean, it goes through the origin.
Right. So that's points on the curve. Is it a straight line?
Yes.
What's its slope?
1.
Therefore, it has to be something like this. There's a straight line with a slope of 1. Now, on the left side of that line, is it a closed dot or an open dot?
Closed.
On the right side of that line, is it a closed dot or an open dot?
Open.
And this value is 1, incidentally. And this value is minus 1. In other words, the slope is 1. So, okay, and now this is the next part to look at. Whenever x is greater or equal to 1, what kind of function is that? Is that a straight line?
No, that's a... No.
It's a parabola.
Yeah.
Okay. So I know I'm looking at a parabola. Well, what's the value of the parabola when x is equal to 1?
When x is equal?
Huh? In other words, when x is equal to right there, what's f of x equal to?
I don't know.
Plug it in. Plug it in. X equal 1.
So it would be 1. Hold on. It would be
1
0.
minus 1, 0. So I know that point is on the curve. And I know what a parabola looks like. The rest of the parabola looks like that, right?
Mm-hmm.
There's your answer. And that is your three-piece wise. That's your function, exactly as they have described it. Now, determine the values of a for which f of x exists. But they sure know how to ask a question in a confusing way. Okay. Mm-hmm. Let me ask it this way. Does f of x, does the limit of f of x exist as x goes to minus 1?
Does the limit of f of x
exist as x goes to minus 1?
Yeah.
Remember what you have to do. You have to approach minus 1 from the left, and you have to approach it from the right.
And it doesn't approach from either side, so it wouldn't exist.
Well, it approaches, but it doesn't approach the same number.
Yeah.
From the left, it approaches 3. From the right, it approaches minus 1.
Mm-hmm.
So, no, it does not exist at minus 1. Does it exist at 1?
No.
Exactly. So, to answer their question, where does it exist? Does it exist at 2?
2. Yeah.
3?
Yeah.
100?
Yeah.
Minus 100?
Yeah.
So it exists everywhere except minus 1 and plus 1. So the answer is A is all real numbers, except A does not exist at minus 1, plus or minus 1. So that's the kind of answer they want. Why they would ask a question like that, I don't know. Wouldn't it make more sense to say, where does it not exist? It's similar to domain questions. Domain, when you say what's the domain of a function, you're really not saying what values can x have. You're really saying what values can x not have.
Uh-huh.
Well, in this question, a can be any number. The limit exists at all numbers except minus 1. In other words, except that number and that number. Those are the only two values of a where the limit is not the same from the left and the right. And that's the key. You have your calculator in front of you?
No.
Can you get it?
Yeah. Here, one sec.
Okay. You there?
All right.
All right. Now, first of all, in calculus, everything needs to be in radians. Always.
Okay.
Calculus does not work in degrees. So the very first thing you need to make sure of is that you're in radians. Can you tell by looking at your calculator whether it's in radians or degrees?
Yeah, I'm putting it in radians right now.
Okay, go ahead. And now do these calculations. In other words, f of x is 3x over x. So the way you would do this, once your calculator is in radians, is you would take the sine of minus 0.3 and divide it by minus 0.1. What do you get?
Hold on. Sine of minus 3 divided by...
Now you see why those are the numbers you have to put in? Because you're taking the sine of 3x. So it's 3 times minus 0.1.
Wait, I'm confused as to why I'm doing it.
Okay, this one is the sine of 3 times minus 0.1.
Oh, okay.
By minus 0.1.
Okay, that makes sense.
That's the first cell that you need to fill in. What does that equal to?
Hold on. I'm trying to get used to this new calculator because we're using an Inspire instead of an 84.
Right. No, I know. I know there's going to be a learning curve there. And
Yeah.
I'm happy to help you whenever I can. You see where the trig button is?
Yeah, I'm slowly figuring it out.
Okay.
So it'd be -3.
No, it'd be negative. It'd be the sine. In other words, this is what you want to put into your calculator. The sine of negative 0.3. Because it's 3 times negative 0.1. And then you want to divide that by negative 0.1. So that's the first calculation you want to do for that first square.
Mm-hmm.
What is the answer?
So I'm trying to get this thing to work.
All right, let me help you.
Divided by 0.1.
Uh-huh. Let me make sure I get the same answer as whatever you get.
I got -2.552.
9.3 divided by negative 0.1.
It'd be 2.9552.
Yeah, these are a little hard. I gotta put my parentheses there before I divide it. Hold on. So I got the sign of negative 0.3. I want my divide sign to be outside of that, and that's negative 0.1. So I got I got 0.05. Is that what you got? What are your decimals after the 5?
So it's sine negative 0.3 over 0.1.
Nope. It's the sine of negative 0.3 divided by negative 0.1.
Okay. It's frustrating.
It's all right. I mean, I understand there's a learning curve. Go ahead and take your time. If you don't, I can tell you exactly what to put in if you need it.
Okay, I almost got it. Where do you use the cursor to?
This is what it looks like on your calculator. That's what it looks like.
Yeah, I got that.
Okay, what'd you get for an answer?
2.9552.
You're not in radians.
It says radians up in the top right corner, though.
Because I got 0.0523. In other words, this is my answer. I'm the one not in radians. Sorry.
It's cool.
No, I realized that I was not in radians. Oh, man. There's one thing about this thing that is tough, and that's putting it in radians. So, no, it really is. It's not so easy to put it in radians. Let me see if I can figure out how to do it here. Okay, so I go to my documents settings, right? Gosh, how do you put this in radians? Do you remember?
The 84?
No, they are completely different. So nothing that works the same on the 84 is the same for this.
I have no idea.
Hold on a second. I didn't realize I was going to have this difficulty. Since I was in degrees to begin with. All right. You're sure you're in radians?
Yeah.
100%?
Yeah.
Okay. Now tell me the second one.
The second one?
The second square on there.
All right. So
you're going to take the sign of
negative 0.0.
Not negative.
Oh, not.
Excuse me. Yes. I didn't see the negative sign. I had it covered up. So it's negative 0.03, like that, divided by negative 0.01.
I got 2.99955.
All right. And what'd you get for the first one again?
2.9552.
What'd you get for the second one?
2.99955.
Do the third one?
It just says 3 point.
And try doing that one. 0. What's going to be the problem?
It won't exist because you're dividing by 0.
Exactly. However, what can you say based on this progression? What is the limit of this function as I approach 0?
3.
Probably. Well, we can't really know until we do those 3. So what's .001.
So 0.001.
Yeah,
Okay,
you
hold
take
on.
the sine of 0.003 and divide it by 0.001.
3.
Just 3, no decimals?
Well, it's 3 point because it's so like close to 3.
Well, we'll call it that. Okay, now do this next one. What's 0.01? There's a purpose to their madness here. 0.01, not negative 0.01, but it's positive 0.01. I don't know where that negative sign came from.
2.999. Whoa, what? 2.99955.
And how about this final one? What's 0.1? When you put in a positive 0.1, multiply it by 3, take the sign of it, and divide by 0.1.
2.9552.
Now, what's this headed for?
3.
What's this headed for?
3.
What's the limit at 0?
3.
Even though that's undefined. In other words, f of 3 is not defined. F of 3 does not exist. And it's not that the limit doesn't exist, it's that f of 3 doesn't exist. Because you cannot divide by 0. Okay? But this limit, as we approach 0, does exist. Because it approaches positive 3 from the left and it approaches positive 3 from the right. Therefore, the limit's equal to 3. Right there. As we approach 0. Okay? So you can kind of understand the point of this exercise is they want you to know that you can fill in these values and you can see what it actually is approaching. And from either side, it's clearly approaching the number 3. Now, I want you to do the same thing on the next exercise. So let's do that.
Okay. So
now, the first square is going to be 1 minus the cosine of minus 0.1, which incidentally, that's a positive number because cosine is positive in the fourth quadrant, all divided by negative 0.1 squared. So come up with that answer.
Divided by negative 0.1 squared.
Which is 0.01. So it's the numerator times 100.
Okay, so I got negative 0.4998.
What's it? Negative what?
Negative 0.4. Oh, wait. I made a mistake with my parentheses.
Just do the numerator only. Tell me what the numerator is. 1 minus the cosine of negative 0.1.
1 minus the cosine of negative 0.1, yeah. But I messed up with my parentheses in the lower quadrant,
yeah,
so.
No, for sure, that Inspire, well, as far as that goes, the TI-84 also, you have to get your parentheses right. But let me tell you something, the Inspire is going to be 1,000 times easier to get your parentheses right than anything else. Jake, I have a 4 o'clock today, believe it or not.
Oh, you do?
Brand new student, so I don't really want to be late for them.
All right, yeah, that's cool.
I think you can see where this is going, right?
I can see.
Yeah. Whatever these numbers are, it's going to point, I don't know that it's 0, sorry, but it's going to point to that. And it's going to point to that. So whatever they're both pointing to, that's your answer.
Okay.
All right.
Well, thank you.
All right, Jake. We'll talk to you next time.
All right. Have a good day.
You too. Bye-bye.